Alright, so this is an example problem from the book where we're given 3 points that create a plane, and we're supposed to find the equation of that plane. So we use the same process that we had before, but we're not given a normal vector in this case. So we have to use the cross product to be able to calculate it. So if we were to just sketch what we're looking at, we have these 3 points, and this is what we're usually given. We're given a point and a normal vector to a general point, but we don't have that. What we have are 2 other points. And so what we're going to do is we're going to create these displacement vectors. We'll call them D1 and D2. And we're going to calculate the cross product to get our normal vector. And then it's the same setup as we've done before with the equation of a plane. So if I take the cross product and I set up my matrix, first off I got to figure out my displacement vector. So I'm just subtracting my ordered triples. So that's the first one we're calling D1. And then D2 I subtract my values. And I get another displacement vector. And so to take the cross product, I set up my 3 by 3 matrix, and then I break that down into my 2 by 2 matrices. And we've got to keep in mind that we subtract the matrix in front of J. I multiply and subtract all of those values as I go through it, and I'm going to get negative 14 minus 5i minus 49 minus 25j. This all becomes negative 19i minus 24j plus 17k. So that is my normal vector. And we can use that now with our general point. So we're going to define our third displacement vector, d3, which is a general displacement vector. So it's going to become x minus 3, I, y minus 5j, and z minus 8k. And now we're going to take the dot product. And so when I take the dot product of 2 vectors that are perpendicular, it equals 0. And so that's why we care about the dot product for these equations of a plane, because it gives us a known value. So I take the dot product, which is equal to 0, and it's also equal to, you multiply the component values, and so I get negative 19 times x minus 3, negative 24 times y minus 5, and 17 times z minus 8, and then just distribute your values through, and you're going to be left with your equation of the plane.